Hello everyone, today we're going to look at integration using the tables. So make sure you have the tables in front of you because I'm going to be referring to them. The goal of this section is to use substitution correctly in order to figure out which of the forms on the table our integral is, and then use that table for the actual integration. The table is broken down into three categories: forms using a plus bu and the square root of a plus bu, forms containing u squared plus or minus a squared and a squared minus u squared, and trig forms. You have to be careful though, because sometimes the form will look like one of these two, but it's actually one of these guys. So I'm going to go through a couple of examples where that's the case, so you just got to be careful and don't just assume you know what it is and try to make it fit. Another good thing to remember is that u is the variable, right? In the table, all of the integrals are with respect to u, so they end in a du, which means things with the a, b, and n are constants. So there's no variables involved in a, b, and n. So for our first example, it says use the table to integrate the integral of e to the x cosine of 3e to the x times cosine of 2e to the x dx. Hopefully this one's fairly easy. If we look through our tables, it's obviously a trig one, and the thing that we want to pay attention to is that we have two different cosines. We have cosine of 3e to the x and cosine of 2e to the x. So that is going to be number 25. So that's cosine of au times cosine of bu du. So a and b are the coefficients of our variable term. So a is 3 and b is 2. And our variable part is e to the x. So u is e to the x. Don't forget, we always have to differentiate it with u substitution. So we need du is e to the x, which is great because that's what we have up here. We have an e to the x dx, and that's exactly what we want given our substitution. So we're going to plug those in. So e to the x dx is du. 3e to the x is au. And 2e to the x is bu. Now we use the table and find out what that integral is equal to. So you have sine of a minus b times u over 2 times a minus b, plus sine of a plus b times u over 2 times a plus b. And the table doesn't include the plus c's just because it didn't want to make it look too messy, so don't forget you always have to add the plus c. Lastly, we're going to plug back in what a, b, and u are. And then our last step always is to simplify. So again, here a is 3, b is 2, u is e to the x. And then simplify. And we're done. So for our next one, let's integrate dx over 16 minus 9x squared raised to the 3/2. So this is something being raised to the 3/2 power. So that is numbers 12 through 16. Since it's 16 minus 9x squared, it must be either 13 or 16. And again, that's because of this minus guy here. Okay. The other ones have a positive u squared. So 16 minus 9x squared is a squared minus u squared. So a squared is 16, u squared is 9x squared. So when we square root it, don't forget to also square root your coefficient. So that 9 is going to become a 3. So u is 3x, du is 3 dx. And then we're going to do the substitution into our integral. So dx is 1/3 du. So we're going to take this guy and divide both sides by 3. And then 16 is a squared, 9x squared is u squared, and so on. We'll pull the 1/3 out, and then if we look at our table, again we know it's either 13 or 16. So this guy, without the 1/3, is number 13. So we're going to use number 13 to integrate it. According to the table, again, we have this 1/3 from before. So the integral is u over a squared times the square root of a squared minus u squared. And again, we plug in what a and u are. And then we clean it up. So this 3 up here and this 1/3 will cancel. And we have x divided by 16 times the square root of 16 minus 9x squared plus c. All right, let's try another one. The integral of 3 dx over x times the square root of x squared plus 4. So the first thing we want to notice is that we have a square root in the denominator. This means that we're going to be looking at 5, 6, 8, and 9 from the table because all of those involve a square root in the denominator. We can eliminate 9 because 9 involves u squared minus a squared, and we don't have a minus a squared because we have a plus 4 here. So we know it's not 9. If it's 8, then our radicand, x squared plus 4, is u squared plus a squared. But if it's 5 or 6, then our integrand is a plus bu. Either of these are possible. Again, just because we have x squared doesn't mean that that's equal to u squared. X squared could just as easily be bu. Okay, so you want to make sure that you're keeping all these possibilities until you've actually eliminated them. So we're going to start with number 8, the one that looks like it's probably that one, and we'll go from there. So if x squared plus 4 is u squared plus a squared, then a squared is 4, u is x, which means du is dx, and we can substitute it in using our u substitution. So 3 dx becomes 3 du, x is u, and then our integrand is u squared plus a squared. Again, we're going to pull out the 3, and this is what we're left with. However, that is not number 8. Right, 8 does not have this u here, and that means it cannot be number 8. So even though right off the bat it really looks like it is, it's got an extra factor here in the denominator that is not actually in our table. This means that we need to try our other possibilities of 5 and 6. So if it's 5 or 6, again we have x squared plus 4 is a plus bu. So a is the constant, that means a is 4. B is the coefficient of our variable, so b is 1. U is x squared, so du is 2x dx. Now if we go back to our integral, we don't have x dx, so what we have to do is multiply and divide by x so that we do end up with an x dx in the numerator. So that's going to be our first step. So I'm multiplying by x and dividing by x. So x times x in the denominator is where that x squared is coming from. And again, that's because I need this x dx from here. Then I do the substitution. X dx is 1/2 du. So again, we're going to divide both sides of that by 2. And then, so that gives us our numerator. X squared is u. And then our radicand, is a plus bu. We'll pull out the 3/2. And this guy here, remember we're debating between 5 and 6. So you want to look at your table and say, well, which one is this? Hopefully we can agree that it's 6, because 6 has that u in the denominator. Right, number 5 has the u in the numerator, but we have it in the denominator, so that means we must be 6. So we continue on. We use number 6 in order to integrate. So we have 3/2 times 1 over root a times ln of all that fun stuff. Plug in all that fun stuff. Right, a is 4, b is 1, u is x squared. So the square root of a are all 2's. Then we clean it up. And we get this lovely guy here. Again, don't forget you have to add in the plus c every time you're doing an indefinite integral. Okay, so let's try another one. Integrate the integral of cosine cubed of 4 theta d theta. So this is a trig function, so we want to look at those last few options. And it's a power of cosine, so that means it has to be number 18. So the power is n in the table, but our power is 3 here, so n is 3. U is what's inside the cosine, so u is 4 theta. So du is 4 d theta. And then we do u substitution. So again, du is 4 d theta. I want to divide both sides by 4 to get that 1/4 du here. I'm going to pull it out. We're going to use the table. And the table says that the integral of cosine to the n is 1 over n, cosine to the n minus 1 of u times sine u, plus another integral. So we got to be careful here. We're not done yet. We still need to continue integrating. Before we do that, we're going to plug in n and u in this part, but here we're going to keep it as u for now because we're still integrating. So u is 4 theta, but again, over here with our integral, we're going to keep it as u. Remember, n is 3. And as I'm saying this, I realized that I wrote a number down here wrong. This 1 should be a 2. So if you're looking at your table, that should be an n minus 2, which is why I have a cosine to the 1 down here. Okay, so that should be n minus 2, not n minus 1 inside the integral. Everywhere else, though, hopefully I've plugged it in correctly. So again, n is 3, n minus 1 is 2, n minus 1 is 2, n is 3, and then again n minus 2 inside the integral, so I have cosine 1. That integral we can do, we don't need a table, we know that from before, so we'll finish it off. Yeah, that's a 2. And I also distributed the 1/4 as I went along, so 1/4 times 1/3 will give me the 1/12, 1/4 times 2/3 gives me the 1/6. Okay, so again, I just distributed the 1/4. And then my last step here is my last u, put it back as theta. So we have 1/4 cosine squared of 4 theta, sine of 4 theta, plus 1/6 sine of 4 theta, plus our constant c. Alright, so we'll do one more. So integrate the square root of 9 minus 4x squared over x dx. So again, we want to notice that we have a square root in the numerator. So before we had it in the denominator, now it's in the numerator. So that gives us the options of 4, 7, 10, and 11. Notice that 10, however, has a positive variable part, and our variable part is negative, so it can't be 10. If it's number 11, then 9 minus 4x squared is the a squared minus u squared. Again, that looks like it's probably the right one, so we'll try it first. That would give us that a is 3, u is 2x, which means du is 2 dx. And if we plug that in using our u substitution, we'll get the following. So dx is again 1/2 du, so make sure we're dividing both sides by 2, so that's where that 1/2 is coming from. X is also 1/2 u, again I'm dividing both sides by 2, so that's where those two 1/2s are coming from. They then cancel, so I've got the square root of a squared minus u squared over u, that dx should be du. Right, I already did that substitution. However, this is not number 11, right? Number 11 doesn't have this in the denominator. So therefore, it cannot be 11, which means it has to be 4 or 7, which means our 9 minus 4x squared is a plus bu. So a, the constant, is 9, and b, which is the coefficient, is negative 4. Okay, so don't forget that negative has to be part of part of b, rather. So a is 9, b is negative 4, u is the variable part, x squared, which means that du is 2x dx. Just like last time, we don't have an x dx in our numerator, so we're going to multiply and divide by x so that we have x dx. So again, I'm multiplying by x and dividing by x, so that's why x in the denominator has become x squared. So our x dx is 1/2 du. x squared is u, and our integral is, our radical is a plus bu. Pull out the 1/2. And then if we look at our table, we have the square root of a plus bu over u, and between 4 and 7, that has to be 7. So again, 4 has that extra u in the numerator, but we have it in the denominator, so it's 7. So again, we continue on with our integration. We have, according to the table, number 7 gives us the 1/2 from before, then 2 times the square root of a plus bu plus a times the integral of du divided by u times the square root of a plus bu. And this integral here is exactly number 6 from the table. So in order to integrate this, we're going to use number 6. So again, this in parentheses is exactly what we get from number 6 in our integral table. Right. And then we're going to plug in our a's and b's and u's. Notice I also distributed my 1/2, so that's why there's no coefficient over here, because a 1/2 times 2 is 1. And then again I distributed, and I have the 1/2 a over here. So now I'll plug in a, b, and u. So we have this very lovely thing, and I'm going to simplify it because I can simplify our new coefficient. And we get this lovely, lovely integral here. So sometimes it can be a little bit messy if you look at all the options. There's lots of parentheses, there's lots of brackets, there's a good amount of ln's. So just be really careful. And also, again, make sure that even if you think you know it right away, make sure you're very careful about what your a, b, and u's are, and especially therefore your du's. You got to make sure that all of the variables are accounted for. So make sure you read through the book and let me know if you have any questions. Thanks.